One area in which microprocessors and microcomputers have had a major impact in industrial process control. There is a wide choice of computer systems which can be utilized for process control and automation of the technological process, ranging from powerful industrial PCs to cheaper microcomputers and programmable logic controllers. Process control involves first measuring system variables such as motor speed, temperature, level of liquid in a tank, thickness of a material, etc. The output of the controller then adjusts the value of each variable until it is equal to a predetermined value called a set point. The system controller must maintain each variable as close as possible to its set point value, and it must compensate as quickly and accurately as possible for any change in the variable caused by, for example, increased load on a motor. A PID controller, PID means proportional integral derivative controller, is an instrument used in industrial control applications to regulate temperature, flow, pressure, speed, and other process variables. This three-term controller uses a control loop feedback mechanism to control process variables and are the most accurate and stable controller. PID controller consists of three terms, namely proportional, integral, and derivative control. The combined operation of these three controllers uh, gives control strategy for process control. PID controller manipulates the process variables like pressure, speed, temperature, flow, etc. The working principle behind a PID controller is that the proportional, integral, and derivative terms must be individually adjusted or tuned. Based on the difference between these values, a correction factor is calculated and applied to the input. For example, if an oven is cooler than required, the heat will be increased. Here are three steps. First, proportional tuning involves correcting a target proportional to the difference. Thus, the target value is never achieved because as the difference approaches zero, so too does the applied correction. Then, integral tuning. This attempts to remedy this by effectively calculating the error result from the previous action to increase the correction factor. For example, if the oven remained below temperature, I would act to increase the heat level over delivered. However, rather than stopped heating, then the target is reached, I derive the attempts to derive the cumulative error to zero, resulting in an overshoot. Derivative tuning attempts to minimize the overshoot by slowing the correction factor applied as the target is approached. The PID controller is used in some systems with relatively low noise level in the measuring channel. The advantage of PID is fast warm-up time, accurate set point temperature control, and fast reaction to disturbance. Manual tuning PID is extremely complex, so it is recommended to use the auto tune function. Triac. The term triac stands for triode for alternating current. A triac is a three-terminal electronic component that conducts current in either direction when triggered. Triacs are a subset of transistors and are related to silicon-controlled rectifiers. As suggested by its name, the bidirectional switch is commonly used as a control element in alternating current circuits. A triac is a small semiconductor device similar to a diode or transistor. Like a transistor, a triac is made up of different layers of semiconductor material. From the figure, we can see that it has three terminals, two main terminals and a gate terminal. This device includes P-type material, which has many free electrons and uh, this device includes N-type material, which has many free electrons, and P-type material, which has many holes where free electrons can go. Solenoid is the generic term for a coil of wire used as an electromagnet. It also refers to any device that converts electrical energy to mechanical energy using a solenoid. This device creates a magnetic field from the electric current and uses the magnetic field to create linear motion. They can be used to slow the flow of electricity in a circuit, making them an example of an inductor or an impedance device. Cars also have a type of solenoid that is really just a motor that happens to work using a coil of wire. The job of the solenoid is to turn electrical energy into movement. There are different types of solenoid: AC laminated solenoid, DC C-frame solenoid, DC D-frame solenoid, linear solenoid, and rotary solenoid. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature change. There are many different types of temperature sensors. Some temperature sensors require direct contact with the physical object that is being monitored. These are called contact temperature sensors, while other sensors indirectly measure the temperature of an object and called non-contact temperature sensors. Non-contact temperature sensors are usually infrared sensors. They remotely detect the infrared energy emitted by an object and send a signal to a electrical circuit that determines the object's temperature. Temperature sensors are used in automobiles, medical devices, computers, cooking appliances, and other types of machineries. We all use temperature sensors in our daily life, be in the form of thermometers, domestic water heaters, microwaves, or refrigerators. A pressure sensor is a device for pressure measurement of gases or liquids. Pressure is an expression of the force required to stop a fluid from expanding and is usually stated in terms of force per unit area. A pressure sensor usually acts as a transducer. It generates a signal as a function of the pressure imposed. A pressure sensor works by converting pressure into an analog electrical signal. When pressure sensing technologies were first manufactured, they were mechanical and used Bardon tube gauges to move a needle and give a visual indication of pressure. Pressure sensors can be classified in terms of pressure ranges by that they measure, temperature ranges of operations, and most importantly, the type of pressure they measure. Pressure sensors are variously named according to their purpose, but the name technology may be used under different names. Some of them are absolute pressure sensor, gauge pressure sensor, vacuum pressure sensor, differential, and sealed pressure. Light sensor is a photoelectric device that converts light energy, that is photon, detected to electrical energy, that is electron. Light sensors seem pretty simple. They sense the light just like a thermometer senses the temperature and a speedometer senses the speed. Temperature and speed are easy to comprehend because we sense them in a straightforward way. But light is very complicated. Light sensors have a lot of uses. The most common use in our daily lives is in cell phones and tablets. Most portable personal electronics now have light sensors used to adjust the brightness. There are different types of light sensors available, mainly photoresistor, photodiodes, and phototransistors. The most common light sensor type that is used in a light sensor circuit are photoresistors, that are also known as a light dependent resistor, that is LDR. Photoresistors are used to simply detect whether a light is on or off and compare relative light levels throughout a day. Photodiodes are another type of light sensor, but instead of using the change in resistance like LDR, it's more complex to light, easily changing light into a flow of electric currents. The phototransistor light sensor can be described as a photodiode plus amplifier. With the added amplification, light sensitivity is far better on the phototransistors. However, it doesn't fare better in low light level detection as compared to photodiodes. A transducer is a device that converts energy from one form to another form. Usually, a transducer converts a signal in one form of energy to a signal in another form. In general, these devices deal with different types of energies such as mechanical, electrical energy, light, chemical, thermal, electromagnetic, and so on energies. Common examples include microphones, loudspeakers, thermometers, position and positions, pressure sensors, and antenna. Generally, an ideal transducer has have light dynamic range, have high dynamic range, high repeatability, and creates low noise. The process of converting one form of energy to another form is known as transduction. Types of transducer based on whether an external power source is required or not is active and passive transducers. Active transducers are those which do not require any power source for their operation. They work on the energy conversion principle. They produce an electrical signal proportional to the input. For example, a thermocouple is an active transducer. Passive transducers, which require an external power source for their operation, is called passive transducers. They produce an output signal in the form of some variation in resistance, capacitance, and any other electrical parameter, which then has to be converted to an equivalent current or voltage signal. For example, a photocell, that is LDR, is a passive transducer which will vary the distance of the cell when light falls on it. This change in the resistance is converted to proportional signal with the help of a bridge circuit. Then a photocell can be used to measure the intensity of light. There are some characteristics or specifications to rate the transducer, that is dynamic range, repeatability, noise and noise and hysteresis. Thank you for today.